So yesterday we learned how to identify a function, and today we're going to learn how to find a function's domain and range. Do you guys remember learning this the first few weeks of school? We just kind of touched the basis of domain and range a little bit. Okay, well let's just quickly, we learned that in a function you can have your x or your and then you were going with the x can be called the what? Input. It can also be called the, no it can't. The domain. And it can also be called the independent variable. Y'all remember now? Okay. So the y is the output, also known as the range, and also known as the dependent variable. So today we're focusing on domain and range. Okay, so right here it says under function basics, we saw the difference between a relation and a function. In either case, we're dealing with relationships expressed as ordered pairs. So over here, this is like a function machine. You put in your input, the machine does something to it, and it puts out your output. You put in your domain, it puts out your range. All of the values that can go into a relation or function input are called the, what am I going to write? Domain. All the values that come out of the relation or output are called the range. The domain is the set of all first elements of ordered pairs, which are what part of the ordered pair? The x coordinates. The range is the set of all second elements of ordered pairs, which are known as the y coordinates. All right, the domain are all x values that are to be used as your independent variable. We don't have to write variable, just write independent. And the range is all the y values that are used as what? Yeah, dependent. Okay, here's our first example. And this one is just kind of like a real life example. We're not looking at numbers. It wants us to state the domain and range of the following relationship. What are we going to compare? Eye color to student's name. All right. Blue, Steve. Green, Elaine. Brown, Kyle. Blue, Marsha. Brown, Miranda. And green, Dylan. Is this a function? What do we look at to see if it's a function? The inputs. And the inputs cannot repeat. So I see blue here, and I also see blue here. Can the inputs repeat? So is this a function? No, it is not a function because blue repeats. What else repeated? Green and brown. Yeah. So I just put blue because it was the first one I saw. Okay, now it wants us to state the domain and the range. Now, it is very important when you state the domain that you state every single input, but you don't repeat it. Does that make sense? So I would only write blue one time. So you wouldn't repeat it. All right, so here we're going to list the domain. So what were my inputs? Blue, comma, green, comma, brown. And I do not repeat any of them, even though they repeat. I only list it one time. All right, let's list the range. What are my range? Steve, Elaine, Kyle, Marcia, Miranda, and Dylan. Why did I list all of them? Yeah, they didn't repeat, so I have to list all possible outputs. All right, next example. State the domain and range of the following relation. Then state whether it is a function. So we're going to go through and we're going to list the domain. All right, what's the first domain? 1, comma. What's the next one? -2, comma. What's the next one? 3, comma. What's the next one? Comma. What's the next one? Do I rewrite 1 since I already wrote it? No. So that is my domain. And by knowing that 1 already repeated itself, is it a function? So no function. Or not a function. What is the range? 3, 7, -3, 5. Do I write this one?
No.
Because I already wrote that. Yes? Okay. Now, you need to understand that when you list the domain and range, you do not have to put them correctly in order from least to greatest or greatest to least. A lot of times you'll see that people do that just because it's kind of proper math, but you don't have to do that. Well, the main thing that you do is that you don't repeat an input or an output if it repeats. Okay? All right, turn the page. This one wants us to state the domain and range for the elements matched in the diagram below and tell if it's a function. So let's write domain. And what are the domains? 3, 4, 5, 6, and 7. Did any of those repeat? So is this a function? So I'm going to write that down here. Yes, function, because no x repeats. Because I don't even care about the outputs, right? When I'm telling if it's a function. Okay, let's do the range. Don't write until I tell you to, okay? So what would y'all say first? 2, comma, no. Why am I not listing 3? It doesn't have an input that's giving you that output. It's just over there. So it's not part of the range. All right, so what would be next? 1, 9, and 12. Do y'all understand why 8 and 3 were not part of the range?
Yes.
Okay. Example 4. State the domain and range associated with this scatter plot. Then tell if it's a function. All right, so let's write domain. And we have to go look at all of their x values. So I'm just going to start on the left so I don't forget any. What's the x value of this dot? 1. Okay, the next one is 2. Do y'all see how I'm just looking on the x-axis at the x value? 3, 4, 5, and 6. So right there, can you tell if it's a function? Yes or no? Yes. Why was it a function? No x's repeat, and if I draw a vertical line, it's only going to hit each dot once. Now we're going to identify the range. So what are we looking at now? The y values of each dot. So on this, I would always start at the bottom of the y-axis and work my way up. So everybody agree? We would start with this one. So what's the y value here? -1. Move up. What's the next y value? 0. And the next one? 1 and 2, 3, and 6. All right, the bottom part says this is an important note to make. Graphs that are composed of a series of dots instead of a connected curve. Do y'all know the difference between just random dots and then like a curve? Yes? These are referred to as discrete graphs. And this is important. A discrete domain is a set of input values that consist of only certain numbers in an interval. So everything that we've done so far has been discrete, meaning we look at it and it has an x of 1, 2, 3, 4, 5, 6. Do y'all agree? There's nothing in between this 2 and this 3. Yes? It's just a 2 and a 3. So now we're going to look at one that's called continuous, and it's going to be totally different how you identify the domain and range. I think discrete is super easy. Continuous is what gets people, and it's what's challenging. So turn the page. Do y'all see the difference between discrete and continuous? So what's the difference? Discrete is just dots. Like if I wanted to graph this, I would have to pick up my pencil. Yes? Continuous is where I have my pencil and it's just going to continuously move and I don't have to pick it up. So my answers will not be, when I have a domain, I'm not going to say 1, 2, 3, 4. Because everybody look at the domain. Could x be -2? Right here? Could x be -2.1? Could x be -2.2? Do you see what I'm saying? So I will not list the domain as 1, 2, 3, 4. I'm going to have to make what's called an inequality. And that's kind of based off of what we've already learned. All right, so here we go. State the domain and range associated with the graph below. Then state if it's a function. We'll look at the graph. Is this a function? Yes, it is. Because if I drew a vertical line, it would only touch one time. All right. The domain, and again, this is where people think it's hard, so please pay attention. What axis am I looking at for domain? The x-axis. So everybody look at the x-axis. Right here, what does this arrow mean? It keeps going forever and ever and ever, yes? And it's slowly going wider. Do y'all agree? So what do y'all think the domain is? It's going to keep, it's all real numbers. It's infinite. Because the x could be anything. Could x be 0? Because look right here. Could x be 0.1? Could x be 5? If this keeps going forever and ever and ever, is it eventually going to be an x of 5? Could x eventually be 100? So do y'all see that you're looking at the x-axis? And if it has an arrow like this, it's going to be all real numbers. Yes? If it has arrows. Now, what's the range? Because it's not all real numbers. Everybody look at the y-axis. Does it have a lowest spot and it's not ever going to go lower? Yes or no? Okay, so what will y's be? Greater than or equal to -3. So when you're writing your domain and range, your domain has to do with x's, your range has to do with? So my ranges, the y's can be anything greater than or equal to, and then what's that lowest spot? -3. This is called a minimum, and so y is going to be anything bigger. Do y'all see where students kind of get confused on this part? Okay, Graphs that are composed of a connected curve are referred to as continuous graphs. A continuous domain is a set of input values that consist of all numbers in the interval, meaning it can be those decimals. But we don't worry about the decimals. What we're saying is y can be anything greater than or equal to -3. So it could be -2.9, -2.8, and so forth, all the way up. Do y'all understand? All right, go to the bottom. It says state the domain and range associated with the graph below and state whether it's a function, but nothing's graphed. So I'm going to give you an equation. Y equals x plus 6. Who can tell me what form this is in? And we learned that y equals mx plus b is, what kind of graph is that? What kind of graph is that? Yes, it's continuous, but like I've been telling y'all this all year. Anytime you graph y equals mx plus b, what's it going to make? It's linear. It's going to make a straight line. Yes? It's going to make a straight line. Is that straight line going to keep going forever and ever? So what do y'all think the domain and range are going to be? All real numbers. But let's go graph it. This is called the Y-intercept, yes? So on the y-axis, put a dot at 6. I know y'all learned this in 7th grade. You won't be required to do this right now. I just don't have it on the graph. What's the rise and the run? 1 over 1. It's not 0. 1 over 1. So rise up 1 over 1. Up 1 to the right 1. Up 1 to the right 1. And would this keep going forever? So take something straight, whatever you have, and connect it. Do I put arrows showing that it keeps going forever and ever? Yes. All right. What's the domain? All real numbers. Why? Because look at the x-axis. Is this going to keep going forever? Yes. Is this going to keep going forever? Yes. So on the x-axis, all real numbers. Now look at the y-axis. Is it going to keep going down forever and ever? Is it going to keep going up forever and ever? It's all real numbers. Okay, if you flip to the back, this is just stuff that you need to know, and it's just examples of domains and ranges from graphs. It's important notes. It says, remember, a domain is the x's, range is the y's. Sometimes it isn't possible to list all the x values and y values because it's continuous. If it's continuous, you're going to write an inequality. Did y'all hear me? If it's discrete, you're just going to write your domain is 1, 2, 3, 4, or 5, 6, 7, 8. Make sense? All right. In a continuous graph, to determine the domain, you have to focus on looking left and right. Domain runs left to right. That's y'all's right. Yes, left to right. And the range runs up and down. So you have to focus on that on continuous graphs. I'm not worried about that. Here's some just notes. If you get confused, you can look at. I'm going to pass out the assignment. We're not going to go over this till tomorrow, so just keep these notes with you, okay? Okay, like I just said, the front is easy because they are discrete. You're literally going to look at the domain and list the numbers. Look at the range and list the numbers. Yeah, so let's do number 1 just to make sure we're all clear. The domain is what? -7, comma, -4, -2, 8, 10, and 19. What's the only thing you cannot do on the front? Repeat if it repeats, right? For example, if they had 2 8s, I only write 8 one time. All right, let's do the range. 12, 9, negative 11, 17, 6, negative 5. So front, super easy. Again, what is the only thing you better not do? Write it twice if it repeats. Okay, turn the page. Do I need to go over this? Y'all are good on this, right? Same thing as the front. Let's go to the hard part. I'm going to help you guys get started. If you will listen to what I'm telling you, it will be easy. Every single thing on this paper is what? Discrete or continuous? Guys, are these just random dots?
No.
Okay. Are these curves?
Yeah.
And they're connected?
Yeah.
These are called continuous. That means you're going to either have all real numbers or an inequality. Does everybody understand? On this page, what are your options going to be? Or an inequality. Okay. Let's look at number 1. What am I looking at for domain? The left and right. The x-axis, yes? Find if there's a minimum or a maximum on the x-axis. So everybody look right here. What is the lowest point? And they're saying on the x-axis, it will never be lower. On the x-axis. That's exactly where people mess up, though. Hey, hold on, guys. I need everybody to stop and listen. This is exactly where students mess up. The domain has to do, you know what? Get a highlighter. The domain has to do with what? I would get 2 highlighters. 2 colors. I'm telling y'all, this will help you. Highlight the domain, the x-axis, 1 color. And that's what you're looking at for the domain. All right? So what is the lowest point on the x-axis? On the x-axis, what is the, I'm waiting for everybody to say negative 2. Are we good? Now, does the maximum have a stopping point, or does it keep going forever on the x-axis? It keeps going. So my inequality would say negative 2 is less than, what else do I need? Why do I need or equal to? Because that's a solid dot. Yes? And domain is x. Am I done? Do I need another stipulation? Am I done? Could I have written this, x is greater than or equal to negative 2? That's it. Are we good? Now we're going to highlight the y-axis for the range. What is the lowest spot on the y-axis? Look right here. That's a dot, yes? What is the lowest spot on the y-axis? Okay. Does it keep going forever and ever up? It stops here, but over here it keeps. So, I only have one stipulation, right? Y has to be greater than or equal to what? Negative 4. Could I put negative 4 is less than or equal to y? Yes. All right. Let's do I wanted to find You want to do 7? All right, highlight the x-axis 1 color, and that's your domain. Did you already highlight?
Yep.
All right, go to the lowest point on the x-axis. What?
Oh, I was going to... Oh.
You're looking at the 1.
What? Yeah, that's why we highlighted the x-axis. Okay. What's the lowest spot on the x-axis? Can it be 3?
No.
Y'all see that open dot? Okay, so what is x going to be? X is greater than 3. Does it keep going forever and ever to the right? Yes. So that's it. Highlight the y-axis. All right. What's the lowest spot on the y-axis? That's not a -4, guys. This is 0. You can't look at because the graph looks like dashes. Just know if this is 0, 0, then that's positive. Yes? All right. What's the lowest spot on the y? Okay, so y is greater than 4. Greater than or equal to or just greater than? Just greater than. Those are all easy. You want to do number 4?
Yeah.
All right, highlight your x-axis. Is there a lowest or highest spot on the x-axis?
No.
What is this arrow saying? It's going to keep going. What is this arrow saying? So what is the domain? All real numbers. Highlight the y-axis. Is there a lowest or highest spot on the y-axis? Or is it going to keep going? So what's my answer? Are y'all starting to get a hold of it? All right, go do number 2, and then we'll see how you do. See how you did. I did domain blue, so I highlight the x-axis. Did it have a lowest or highest spot? It had a lowest spot, and what was that spot at? Negative what? -2. So x has to be greater than or equal to -2. Highlight the y-axis. Did the y-axis have a lowest or highest spot? Lowest or highest? Lowest. What was the lowest it ever went? And then it's going to keep going forever, yes, after that? So y is what? Greater than or equal to 1. Are y'all starting to get the hang of it? Y'all want to do one more? On number 3? All right, y'all try it on your own. All right, highlight the x-axis. Okay, looking at the x-axis, is there a lowest point or a highest point? No. This is the maximum it can be. Yes? Okay, so x has to be less than or equal to or just less than? Just less than +4 because it's moving to the left and it's going to keep going. Make sense? It's kind of like when you graph. See how it's here and it's shaded to the left. And it's shaded to the right. You go the other way. Okay, let's do the y-axis. Is there a minimum or a maximum? A minimum amount, right? So if there's a minimum, you're going to have a greater than sign. If there's a maximum, you're going to have a less than sign. Here's the minimum amount y can be. So y is anything greater than -16. How did y'all do? Are we doing okay? All right. If I was y'all, I would do these 4 before you leave and maybe come get them checked with me. Because the rest is easy. Yeah, these.